Okay, let me welcome you to the 43rd lecture of NPTEL online certification course Drilling and Blasting Technology. For last couple of lecture, we are basically solving different tutorials related to the cost analysis and performance of drilling and blasting operations. So, we are discussing about costing analysis. So far we have covered more or less the theory part, which is drilling and blasting, the practice which is carried out in surface and underground mines. In surface, it is basically the bench blasting. In underground mines, we have basically discussed the drive or blasting carried out in the drives and drifts in the mine, that is discussed, and different drilling pattern and blasting patterns are also discussed. So, in the tutorials we have seen the performance of different machines, performance of blasting operations, those we have already covered, and in last couple of lecture we are discussing about the cost analysis system, how the different cost heads are calculated for drilling and blasting operations. So, the theory part we have already covered in last two lectures, where we have seen how the different cost heads like capital cost, maintenance cost, operating cost, all these are calculated. So, in this lecture we will solve one problem related to the surface drilling. So, let us see the problem. In this case, our problem is that consider a mine which is using 160 mm diameter drill machine for carrying out drilling operation, that is the drilling of the blast holes in a sandstone rock mass. Say consider the bench height is 10 meter and 12 meter drill holes are drilled, that means 2 meter sub drilling has to be carried out, and the drilling rate is given. You understand that the penetration rate and drilling rate is different, that is already discussed in the previous lectures. Penetration rate is the speed of the drill bit in the rock, and drilling rate is the overall performance drill machine gives, that includes setting time, rod changing time, propelling time, all these are included. So, the drilling rate is directly given here, that is 20 meter per hour, and the drilling costing is required to be expressed in rupees per meter. In fact, drill cost may be considered in different way. It can be directly considered with the total production, that is in meter cube or ton, but often drill cost is expressed in terms of meters, especially where the drilling operation is given on outsource basis. So, if it is given on outsource basis, then we go for calculating this in rupees per meter, because the outsource organization may claim that there is 2 meter sub drilling, which does not included in the includes in the performance, that is in the production of the mine. So, that is basically additional drilling requirement, but that is not related to the production. So, that is why it is not included there. So, outsource organization may ask for payment in rupees per meter. So, in that case the drilling cost is determined in rupees per meter, not in rupees per meter cube. Some data are given, that is the price of the drill machine, the diesel consumption rate, and diesel price is also given matching the current price of 2022. Bit life is given, bit price is given, and other data are required to be assumed. So, let us considering this, we have to solve this problem, we have to find out what could be the possible drilling cost for this type of situations. So, actually this solutions are there in the slide, but I would like to carry out this solution in a white page here, and after that I will show the solution in the slide itself. So, let me solve it in this whiteboard. First is that it is given this is the bench of 10-meter height, and we need to carry out drilling of 12-meter height. Okay, so, this is 12 meter. So, there is a sub drilling of 2 meter. Okay. Now, in this condition it is given to us that the machine price is ₹1 crore. Crore is basically an Indian terminology which is equal to 10 million. So, this is 1 into 10 to the power 7 rupees is the price of the drill machine. It is also given that the hourly diesel consumption is given 20 liter. Diesel price is given ₹100 per liter, and drill bit price is given 10,000 rupees, and bit life is given in terms of meter, that is 1000 meter. Now, while we are solving this, first we have to find out the capital cost. So, first cost head, that is capital cost. So, capital cost we know this is the owning cost of the machine, the price is given. So, we have to assume the life. So, let us assume the machine life is 45,000 hour, which allows us to use the machine for 10 years with 4,500 hour per year. So, this is the utilization possibilities for this machine, drill machine we are considering, and we are also considering that this is allowing our machine to run for 6 hours per shift, 3 shift per day, and 250 days per year of operation. So, these are our assumption. So, 6 hours in 3 shift, So, this is 18 hours per day, and 250 days. So, 18 hours per day 250 days. So, that is we are getting 4500 hours okay, per year. So, this is our utilization we are expecting. So, capital cost we know that this is capital cost is the price minus scrap value divided by life. So, this is the easiest way to calculate the capital cost. There are other way where we consider other components also like depreciation, interest, but for this very first tutorial we are not considering those components, but anyone if wishes they can calculate that one. So, we consider the scrap value is 0. So, now from this we are getting the capital cost. So, capital cost is becoming now 10 to the power 7 by 45,000. So, that is coming around in rupees per hour. So, we know hourly our drilling rate is given meter per hour. So, if we convert this, so this is 10 to the power 7 divided by 45,000 into 20, that is rupees per meter. So, from there if we calculate it, we get it 11.11 rupees per meter. So, the capital cost, that is the owning cost of the machine, is coming 11.11 rupees per meter. Anyone may have other components here like interest, depreciation, those can be calculated here. So, say interest rate you can have say 10% or so, that can be calculated here, but we are not considering for this calculations. These are neglected, these heads are neglected for this very first calculation, but anyone is having the option they can have it to utilize the interest rate here. So, for having that interest rate, basically you have to get the 10% of this as the value of as interest or so. So, that can be possible. Okay. So, anyway we are not considering that. So, straightway 1.11 rupees has to be added as interest component here, that is based on the 10% interest rate. So, we have got the capital cost has come 11.11, it is in rupees per meter. So, I think this is now clear to you how to get the capital cost. Let us so, this is capital cost we have already calculated. So, next part is that we have to calculate the maintenance cost. So, there are many ways to calculate maintenance cost, but generally the easiest way to calculate it based on the percentage of the capital cost, and in last class we have shown you that one very common idea is that we can consider for the diesel operated machine, it is the 20% of the capital cost. So, 20% of the capital cost is can be considered as the maintenance cost. So, in that case it is coming around 2.22 rupees per meter. So, this is the easiest way. For electrical equipments we consider it is 10%, and again let me explain you that if the mine is already under operation, in that case the maintenance cost has to be carried out, considering whatever is the actual maintenance cost incurred by that machine during that particular year, and that description can be obtained from the stores from where the spares are issued to the machine. Okay. So, from that cost head of the store, the particular maintenance cost of the machine can be easily calculated. We have already got capital cost and maintenance cost. So, the next heading, cost head, that we need to calculate is the operating cost. Now, operating cost has different cost heads. The first cost head in the operating cost is the power cost. So, this power cost means it is the direct consumption of the fuel for operation of that particular machine or equipment. So, for this case we know it is already given that this is actually consuming 20 liters of diesel per hour. So, 20 liters of diesel per hour is being consumed by this machine, and see, in general most of the diesel engines, they are not only diesel engines, electrical also, the power consumptions are basically defined in terms of consumption per hour. Say it is our very common idea that for car, vehicles, etc., generally we ask it is in kilometer, how much kilometer the car will run in that 1 liter, etc. But it is not basically based on that, it is basically the consumption of the fuel is depending on the capacity of the engine, that is what HP is the engine, and at what load the engine is operating. That means, if the engine is in say running at lower RPM, then the fuel consumption is less. If it is running at higher RPM, then the fuel consumption will be more. So, that is the depending on the load on which the engine is supposed to run. So, this 20 liter per hour is considered as the fair load, that most of the time the engine is operating on that load, that is generally these loads are coming around 80% or 90% of the full load condition. Okay. So, that in that condition the engine consuming the fuel is considered as the fuel consumption, and that is expressed in hour. So, that is same is there for the our vehicle engines, etc. So, that engine is consuming that fuel, but that per hour is converted here in kilometer. Okay. So, that is the common belief. That is why you can understand, if your engine is on and if you are not putting the vehicle in gear, so the fuel will be consumed, consider even the vehicle is standing at one place. So, fuel consumption is not related to the running of the related to the kilometer runs, it is basically depending on the hour at which the machine is running and the load onto the machine. Okay. So, that is why the power cost is basically the fuel cost, that is the consumption of the fuel, that is 20 liter per hour, and its cost, that is 100 rupees per liter. So, again this is coming in 2000 rupees per hour, and again we have to convert it into rupees per meter. So, we know the drilling rate is 20 meter per hour. So, this is converted to, so 100 rupees per meter is coming the fuel cost. So, now let us place it in a systematic way. So, the fuel cost is, power cost is coming 100 rupees per meter. Okay. So, next head is drill bit cost. There may be many consumables in a drilling operations. Their drill rod may be considered as the consumables, but for this particular calculation we are only considering the drill bit is the consumable part, and that is why the drill bit cost is considered as the consumable. So, this is coming under consumable. We are not considering any other consumable in this particular calculation. Okay. So, make it basically for simple, make it simple, we are not considering the many calculating part here. So, drill bit, we know drill bit price is price by life. So, the price is 10,000 rupees and life is 1000 meter. So, this is rupees, this is meter. So, it is 10 rupees per meter. So, this is straightway, as the drill life is given in meter, it was easy for us. So, 10,000 rupees divided by 1000 meter is giving us the 10 rupees per meter directly. So, again let us place it here. So, this is 10 rupees per meter. Now, next is the manpower cost. We have already discussed in our previous lectures that manpower cost basically comes from the average cost of salary heads. Salary head means it is not only the salary, associated other parts are also included. So, this is the cost to company for having a manpower is basically considered as the manpower cost, and considering this we basically rationalize it considering the term called EMS, that is the earning per man shift, that is basically considered, which is expressed as the average salary of the direct employment in that particular organization, okay, or in the unit operations, direct employment in the unit operations, not the supporting employment. So, that is the cost of that basically considered here. So, this is manpower cost is basically considered as the number of manpower into EMS. So, that is the rupees per shift, number of manpower and the EMS. So, that is basically rupees per shift, and we have to convert it to the rupees per meter. So, this is number into EMS divided by per shift production. Now, in our earlier slide we have already discussed, we have considered that there are 6 hours operation in a shift, and if it is a 6 hours operation, so shift operation is 6 hours. So, drilling obtained from 6 hours is 6 into 20, that is 120 meter will obtain in one shift. So, we will convert this shift into the meter. So, for this now what we will do, this is divided by 120 meter. So, it will become rupees per meter. So, now for this we have to calculate. Let us consider our EMS is 2000 rupees and number of person required is 2. So, that is one driller and one drill helper. So, that means it becomes 2 into 2000 divided by 120. So, that comes around 33 rupees per meter. Okay. So, now it is 33 rupees is the cost coming in manpower head. So, you can find out, let us put it in a better way, 33 rupees rupees 33 paisa rupees per meter. Okay. So, now if we put it in a table, then we can see the capital cost, ₹11.11, maintenance cost ₹2.22, operating cost, that is together this is coming ₹143.33. So, this is coming ₹143.33. Okay. So, that is why in this 3 cost head, capital cost head, maintenance cost head and operating cost head, our total costing is ₹156.66. So, now if we are considering the 4th head, that is the overhead, this overhead cost is basically the cost incurred by the head office, by the other supporting staffs, recreations, etc., timekeepers, legal requirements, all this comes under this overhead cost. So, this overhead cost, let us consider it is the 10% of the sum of A plus B plus C. So, that is why it is coming 10% of ₹156.66. So, it is coming ₹15.66 per meter. So, the total cost is coming so this is adding with this. So, this is 2, 3, 2, 6, 1. So, the total cost is 7. Total cost is ₹172.32. So, that means the total cost is this one. You are expecting from the drilling carried out by this condition, approximate cost which will incurred by you per meter of drilling is ₹172.32. So, if you are considering for outsourcing this, you have to add above this the contractor profits, that may be again around 10% of profit you have to give. So, this will come to 10% of that, means again 17 rupees. So, this will come to approximately come to 190 rupees if you are allowing this to be operated by the outsourcing plan. Okay. So, this one is already there, and in this case let us look into the slides, because this is already solved in the slide. So, this is the drill machine. You know, drill machines are operating like this. So, first this is the changing of the drill rod is removed, the second rod will be removed now. This one is now, the mast is now adding with the second rod. Now, the second rod is being removed. So, as the second rod is removed, now the machine is now ready to move from this hole to the next hole. You can see the propelling light is already given. So, that means anyone near to this machine must move out. The machine will be propelled now. So, this is the sign, safety sign for that. So, now this machine is moving. So, this moving is basically the unsafe act. Logically, whenever the machine has to move from one place to another place, this must be this drill rig or drill must be in the horizontal position, not in the vertical position. But here it is as moving a very small distance, the operator is not doing that one. It is allowing the move on mast keeping vertical condition only. Okay, now the second drilling will be carried out in this place, second hole drilling will be carried out. So, now let us see our assumption, we have already solved this one, yearly 250 days working, 18 hours per day, that is 3 shift with 6 hours and 6 actually operating 6 hours, shift may be of 8 hours or so, but 6 hours is the utilization machine operating hours. Drill machine life is considered 10 years, that is 45,000 hour, considering 4,500 hour per year. Then we have calculated the capital cost, that is the 10 million rupees or 1 crore rupees, 10 million rupees, that is the price of the machine divided by the life, and in each hour we are achieving this 20 meter drilling per hour. So, that is why it is coming in rupees per meter 11.11 rupees per meter. Maintenance cost we have considered 20% as the machine is diesel operated. So, considering 22%, it is 2 rupees 22 paisa per meter. Power cost is the diesel price 100 rupees, 20 liter per hour is the diesel consumption and 20 meter per hour is the performance found. So, that is why it is coming 20 into 100 divided by 20. So, 100 rupees per meter is the fuel cost. Similarly, bit cost is coming 10,000 rupees by 1000, 10 rupees per meter. Manpower cost we consider one driller and one helper. So, 2 person 2000 rupees EMS. So, the manpower cost is 2 into 2000 rupees for 6 hour shift. In 6 hours the drilling achieved 6 into 20. So, 120 meter. So, the manpower cost is coming 33 rupees 33 paisa per meter, and overhead cost considered 10% of the all, which is coming 156 rupees 66 paisa. So, 15 rupees 66 paisa. So, thus by this way total cost is coming 172 rupees 32 paisa. If you are considering the contractual works, then in that case you have to consider the profit for outsource organization, and that may be 10% of the total cost, and that will come around 17.2 rupees. So, altogether then it will coming around 190 rupees. Okay. So, this is the assumption we consider, and this is more or less by this way we can solve this problem. This is the first problem we have solved in this class. We will continue with solving the drilling problem related to the drill cost related to the problem for the underground drilling operations, which holes are used for the underground blasting in drifts. Thank you.